Well, that right there is my farming music, and we've got some farmers out in the neighboring field there. You can see they're doing hay baling operations, basically cutting the grass there and running that little box-shaped thing, and that basically grinds up all the grass into a big ball and spits out these round bales. They're about 500 pounds. We had one of them for some goats several years ago, and those things are so heavy you can't move those by hand. I had to take we had a minivan at the time, and we had to push those things around into the goat pen, so they are pretty heavy. So watch out if any of those fall off a truck there when you're heading down the road. All right, let's see. What does it look like outside? Let me bring up my video feed here. And there it is. There's the current view outside, looking at pretty much scattered clouds, just mid and upper level layers. And we know from yesterday that's probably originating from some of the convection up along that front, coming through the central Mississippi River Valley into Arkansas and Oklahoma. And we've got the dusk starting to settle down here in Texas. Let's check out the upper air, or the surface pattern here. Get this out of the way. And there you can see a very unusual pattern for this time of year. Well, I wouldn't say unusual, but it's not very common. What we normally see here is just straight flow out of the south going all the way up to the Dakotas. And what we've got here instead, we've got this front pushing south into Oklahoma. It's already cleared Paris, Texas, cleared Wichita Falls, and through Childress and even out to Amarillo. And we can see it's kind of banked up against the higher terrain up into the Rockies and Colorado right there. And all of that is being driven by northerly flow up to Missouri, Iowa. And let's take a look up there. Remember, a couple days ago we were seeing 101 to 103 degrees in Kansas. That's dropped by about 20 degrees. And even up in Chicago, they've cooled off to 74, 75 degrees. Let's just see how cool the air is. Think about the coldest temperature I can find. Looks to me like it's in maybe London, Ontario, 62, 63 Detroit. Okay, so that's kind of where the coldest area is at the surface. And ironically, as you go further north into upper Ontario, we get right back into the 80s, and even 84 up at Fort Severn along the Hudson Bay region. So that's kind of strange. You know, you head north and temperature goes up by 20 to 30 degrees, but if you go a little further north, then we do catch up with the polar front. And there it is. Just taking a quick look around the U.S. and Canada at this time. What kind of weather pattern do we have? Well, looking at Arizona there, looks like 99 degrees at Phoenix, so that's a little bit on the mild side. We can see southwest winds in the Las Vegas area, so that's indicative of tropical air covering that region. And then when we get a little bit further north, we can see some north winds picking up right up here in Idaho and Oregon. See that right there? So even though we do have 91 degrees in the inland desert areas, this suggests that we have cold polar air starting to make its way inland. So I would probably put the leading edge maybe something like this. And then the much colder air is lurking offshore. And we're going to see a little bit more of that on the thickness analysis. And let's take a look out to the east and see what we got. We got very mild conditions. I would really love to be in upstate New York right about now with these mid-60s here. That's definitely jacket weather. But if we go a little bit further south, we can find the frontal boundary. So it's somewhere in between this northerly flow and down in the Carolinas and Georgia, this southerly flow. So we're going to put that probably right here through northern North Carolina into the Knoxville area, Nashville, and Memphis. Okay, so that's part of the same front that's affecting Oklahoma and the Red River Valley of Texas. So that's cool air, pretty good chunk of it on its way south. And sometimes I like to take a look way up north and see what's going on. There's Siberia there, 40s. We can see a little bit of a front there. See these 70s in the inland areas. I think we've probably got a boundary looking something like that right there. And indeed, we do find the lower pressures right there. There's the 998 millibar low. So probably if we do the isobars, they're going to be looking something like that right there. So low pressure area on its way eastward, and that should be in the Alaska area in the next couple of days. There's the Canadian High Arctic. There's a little bit of bad data. For example, the 68, that's probably incorrect. But elsewhere, looks like lots of 40s, 30s and 40s, very typical for this time of year. And then let's drop into Alaska. If I can get these windows working correctly. There we go. Okay, there's a look at Alaska. We've got 72 there at Fairbanks, and this is about 6 p.m. About 5 or 6 p.m. local time. Okay, so this is very normal weather for that area. And we can see that Alaska, in synoptic scale patterns, it's under a large southerly flow. We can see most of the plots here coming out of the south, and then we've got a little bit of westerly flow out in the Gulf of Alaska, or Bering Sea. Yeah, Bering Sea right there. So probably that may be that front extending on into Siberia like that. So now we've got a very good picture of what's going on. And we can kind of tie that in with the surface charts, or the upper air charts, I'm sorry. So a little bit of thunderstorm cluster action south of Little Rock through Pine Bluff into Arkadelphia and down to all the way to about to McIdas. I'm trying to remember the name of that town. South of Tulsa, south of I-40, McAllister. Okay. Yeah, that'd be kind of weird if there was a town named McIdas there in Oklahoma. Be going there for satellite training all the time, I'm sure. But yeah, there's the boundary, and maybe we can see that on the deformation chart. This is kind of a new favorite chart that I'm looking at, and we can kind of make out the outflow bubbles right there. So that's a good way to find your disturbed areas of flow. Looks like the frontal boundary right there, and then some other boundaries in here. And if I was looking for convection, I would probably take a closer look at the data to see what's causing that right there. And down to the south, that looks like the sea breeze. So there's a lot to be gained by looking through some of these charts and trying to put them to good use. Obviously, deformation and axes of dilatation, that's not your typical chart that you see people turning to, but you definitely can use it. And let's take a look at, let's see, maybe the northeast U.S. I just want to see very quickly if we can find that polar front. Okay, that's going to be under theta. However, this may not be quite coarse enough to really resolve the frontal boundary. Several days ago we talked about that, how if you bring down the smoothing, you can really bring out the fronts, and I can see probably what looks like the frontal boundary right here. But if this wasn't so smoothed over, we could probably follow it all the way up into Montana, something like that. And then it looks like there's probably some other boundary right here through Nevada. Okay, let's see here. I'm looking at the background here, and I'm going to put up the outside chart real quick. The reason being, I've got some customer data up and I don't want that accidentally let's see. Yeah, it's going to be the southern window here. Give me just a second and let me get my desktop cleared away. That's probably one of those things I should check before I go on the air. Okay, all right. We're looking good. Let me bring back the charts. And there we go. Marginal risk, and you can see that that's pretty much along the leading edge of that front. And then where we have the baroclinic low out in the Virginia area, North Carolina, we've got a bit of an MCS developed out in that area. So maybe we can bring up a little GR level 2. So let's see, we'll head up maybe to Dover, check their radar, and get that loading. And this would probably be a good time while that's loading to take a look at the satellite imagery. And there's those storms along that frontal boundary. And while that's loading, let me take a look in chat here. Let's see, we got Burl H, Kevin McKinney, Ryan Toomies, Eddie W., and Sue M. and Ron Chaffant. Alexi says, very hot today, 103. And down to 98 now. EAS Fan 51. Kevin says, audio's sounding good. Stephen Williams says, it's a cold Saturday afternoon in the southern hemisphere. Sagan's Run, that's a new name there. It's hot in DeWitt County, Texas. Stephen Williams, loving the blue skies of Texas. Mike Estwick saying it's 73 in Denver. They've got those upslope storms, and you can definitely see them here on the satellite loop. Denver being located right in here. And some of the storms have already moved off the front range into the prairie areas right there. So you can see some tops right there around Lyman. And they're heading on off towards Kansas, probably going to be out there by midnight. SPC Kingsport, new name here. Haven't seen that one before. Welcome to the broadcast. Sagan's Run says it's 103 in Victoria. And Alexei mentioning the 103 temperature was regular temperature, 110 for heat index. We have jumping flash here. And Sagan's Run looking for cooler weather where he is on Thursday through Sunday. Mick checking in morning there in Australia. And Sagan's Run starting to see his cows doing the we want to rain dances around the hay bales. All right. So let's go into the rest of the charts here. This is the 200 millibar analysis. This is up at almost 40,000 feet. And what we notice here, big high pressure area aloft. And this is centered over northwest Oklahoma. And there's that big anticyclonic circulation. So that puts Texas under easterly flow. And you probably saw those clouds on the opening sequence spreading from left to right. That's the east to west movement. And surprisingly, with the frontal boundary through Arkansas into Oklahoma up to Amarillo, we're actually getting convection underneath that ridge right there. Now, normally it's very difficult to get convection underneath these upper-level highs because this is a big area of upper-level subsidence. We get sinking motion, and with sinking motion we get warming and adiabatic warming of the air, and that basically gives us an inversion. So let's see if there's any sign of that on the SKUTs. I'm going to go to the Fort Worth SKUT for this morning. Okay, so we got Fort Worth coming up there. Well, we can see some warmer temperatures aloft, but not very much in the way of a mid-level inversion. So let me try going up to Norman. We'll go a little bit closer to that high. And yeah, we see a little bit of warm air aloft, but cool in the mid-levels. And that's probably a big factor in allowing the thunderstorms to develop there in Oklahoma. You can see a pretty good lapse rate right there from about 850 millibars all the way up to 500 millibars. You can also see that variable flow aloft, and up at the upper levels of the troposphere we have easterly winds indicating that the high is further to the north. And then we go up into Dodge City, and that's probably right in the middle of that high pressure area, and there we can see the big upper level high, the warmer temperatures aloft. But I guess what has happened is there just has not been enough subsidence for a long enough period to really develop this subsidence inversion. So we're left with some cool air in the mid-levels and just enough lift along that front to get storms forming. And if we do our lifted parcel method here on the Dodge City sounding, maybe go with a high of 88, maybe a dew point of 63, well, we can see a little bit of that capping in the upper levels, and it's almost not quite unstable, but there's a little bit of instability here and there. And I think once you go further down in Oklahoma, where the moisture is a little bit better, and where you're a little bit further away from the high pressure area, you've probably got better opportunities there for convection, especially in the low and mid levels of the atmosphere there. Okay, let's go to the thickness chart and just look at this real quick. Well, it's pretty easy to pick out the front. Low pressure area right there over the Virginias. And I think we can kind of trace out a warm front like that. And then we see the cold air advection back in the Great Lakes area around Illinois, Indiana. And we can pretty much bring that cold front right through this trough and back up into Colorado like that. So this is the layout of the fronts this evening. Cold front on its way south into Texas. It's not going to bring much cold air, but certainly we should get a little bit drier conditions. And up north, here's the next cold front. Looks like maybe a little bit of a wave here in Montana. Then low pressure right there, and then probably the next front situated something like that. So that's the setup for this evening. A succession of cold air masses coming south, and there's one over the Great Lakes right there. Try using yellow for that. And then here's the next shot of cold air coming south. So if this was January or February, we would be getting some very cold weather into the U.S. But since it's summer, these air masses modify very quickly. Now let's take a look at what's going on to the south in the tropics, and not much. 5-day calling for, well, we were looking at one easterly wave out in this area here, south of the Cape Verde Islands. I guess that's gone from their analysis charts. However, on the polar orbiter data, we can see a little bit of that unstable this unstable air mass. This is basically along the intertropical convergence zone. This is normally where we find it this time of year. Looks like maybe one little wave through here, but other than that, all the way to the Caribbean looks pretty quiet right now. But as we've mentioned over the past few weeks, and as Ryan has told us, sea surface temperatures are above normal out in the Atlantic. So as we get further into summer, we're probably going to be looking at kind of an active pattern here from the Atlantic into the Caribbean. Closer to home, earlier today, there's that frontal boundary, very easy to pick out. And as you go into the northeast U.S., you pick up a little bit of that comet cloud. This is actually kind of a baroclinic leaf right there. So you basically have the jet stream feeding into the backside of this cloud feature. So this is an area of potential baroclinic development, and we would be looking for the cold front to kind of be set up something like that. So this right here, that's kind of like the little dry slot. And back here, this is the comma head, the deformation zone. And then the rest of it is basically the comet cloud itself. So as these end up evolving, they develop into more of a classic comma shape. So what you're seeing here, this is kind of pretty early in the system's life cycle. Okay, then further to the south, the Gulf looks pretty quiet. Don't see any tropical disturbances. But we know from what we saw in the chart runs last night that we're going to get the tropical express starting to come up into Texas the first week of August, and that's going to start bringing some easterly waves into the Gulf and into the state later on. So the pattern will start getting a little bit more wet here again in about a week or two. Okay, so I think we're probably about ready to head into the forecast. There's obviously not too much going on. And hopefully the stream is holding up better. I know we had some people dropping off last night, and apparently we were lagging a bit. So I shut off a lot of my devices here, and hopefully we're not having any problems with that going on right now. Okay, let's see here in the Midwest what's going to be going on overnight. There's the high resolution rapid refresh. And overnight we're going to see some of that MCS activity in Colorado on the high plains. That'll be moving into Kansas, and you can see that there's a little bit of inflow into these storms here. And by inflow, I'm talking about this high pressure area here. So we've got that clockwise flow around the high, and that brings a little bit of pressure gradients, a little bit of geostrophic wind into this system. So that's helping to feed it with a little bit of moisture and inflow. So that should keep those storms going, I think, through some of the evening. And it looks like it lasts until just after dawn. So bringing a lot of rain to the western counties of Kansas right there, but not getting too much further than that. And then we'll see what happens tomorrow night when things redevelop. With this flow continuing to push southwestward, we may be in an even better upslope pattern tomorrow. So we may see the MCS persist a little bit later into the evening hours. Okay, then as far as the GFS goes, this is the 850 millibar chart. And what we're looking at here is dew points up at about 5,000 feet. And you can see that we've got considerable depth across Oklahoma. So apparently not only do we have cool air in the mid-levels, but we've got great moisture depth. So even with that high pressure area aloft, this is telling us pretty plainly that we have got a lot of moisture to work with. And let me go back to that sounding. Let's see here. It's a little bit dry right off the surface at Norman. But let me check Springfield. Yeah, look at that moisture there. You've got basically low 70s dew points and only a very gradual drop-off. Considerable moisture topping out at about 13,000 feet there. So Definitely got a lot of juice to work with there. So we'll just kind of run this forward and see what happens. By tomorrow night when we do the webcast, that band of moisture will be pushing southward into Texas. And now you see it across East Texas, up into the Dallas area and up to Amarillo. And you can also see a little bit of that easterly component right there. So any storms that get going on the high plains, they have the potential to either push east or they might work southeast down that boundary. This is a good pattern for northwest flow thunderstorms. Okay, the moisture will pile up in Texas over the weekend. And then by early next week, a lot of the moisture will be pushed into New Mexico. The front will make it westward, and we'll see rain chances going up for the Four Corners area, Albuquerque and Las Cruces there. And you can also see a lot of drying coming into the Midwest right there. High pressure, just basically forcing a lot of cool, dry air into the southern U.S. So for the first week of August, we're going to have a front in this area, and let's switch off to the surface chart here. Okay, there's the high pressure area right there over the Great Lakes. And there's the front. And then over the weekend, tomorrow is going to be Saturday, and we're going to have the front all the way down past Atlanta, all the way into East Texas and into the Panhandle like that. So it looks like a good chance of rain there for the South Carolina and Georgia area. And then for Sunday, the front will make even further southward progress. Very slow movement of this high. And then for Monday, I think what we're looking at is probably just kind of a quasi-stationary front there in Texas. Most of the convection should be on the high plains right there, where we have the better heating and the orographics. Tuesday, things look still pretty active there in Colorado and New Mexico. Some of that ridging starting to move southward into Texas, and that puts us under northeasterly flow. So it looks like some cool and dry evenings. Should still be warm during the daytime. For Wednesday, it looks like maybe a little bit of an upper level disturbance gets started up right here. We've got that easterly upslope flow in Texas, so some good patterns coming together here for rain around midweek. And there's Thursday. Looks like maybe a little bit of baroclinic development down in the lower Rio Grande. Looks like another front coming south. This has the look of an Alberta clipper right there. And that's being driven by this high way up in Saskatchewan. Then by next weekend, here comes the next front. Unusual pattern, definitely. Yeah, this is almost like an October situation. Front coming southward, being driven by this 1028 millibar high. Texas starting to get a little bit of southerly flow. In fact, I think we've got probably a weak low-level jet right up the Mississippi River Valley. And then, let's see here, going into Saturday, frontal system sweeping into Indiana, into Arkansas, and all the way down to North Texas. Wow, so I guess we're going to have some weather to look forward to. Next week, we're going to have kind of an early jump on some of this extratropical forecasting. And I'll probably have to pull out some references for that. We can look at some of that stuff. And then towards Monday and Tuesday, we see a little bit of an occluded front here. This is an occlusion. This is kind of a cold core system over Michigan. You can see the thickness lines are kind of stacked like this. So that tells us that the gradient, the frontal gradient, is way out ahead. So it's way out here in the eastern U.S. So that's the true location of the baroclinic system. And then what we have out here, this is kind of the tail end of the wrapped up cold air over the Great Lakes area. So a little cool air filtering down into Arkansas. You can definitely see that cold advection through this area, and a little bit of a cold pool over Illinois. And then going into the 8th and 9th, basically we have that high pressure area merging into the Bermuda High. Bermuda High starting to become active again. Looks like another shot of cold air coming south. And we're starting to get within range of the eclipse weather. And I think probably in about another week we're going to have somewhat of an idea what kind of pattern we're going to be in. And I might be able to make a forecast there of where the best viewing conditions will be based on the long wave pattern. At this point, though, it's too early to tell. And I think especially with these systems moving south out of Canada, these migratory systems, those are a lot more difficult to deal with than the normal pattern of where you have low pressure in Colorado and Wyoming and southerly flow from the Gulf. That's a little bit more predictable in terms of sunshine. So we'll probably have to wait another week to a week and a half to know what the eclipse weather will be. And I'm planning a special segment here in the next week where we'll look at some climatological information to kind of figure out where the best viewing opportunities will be. Okay, I think that will just about do it. I'm going to take one more look at chat. Let me get our music queued up here. Give me just a second. I just want to hit the button and go with that when we're ready. And let me take a look at the chat here. How do you decide if you should analyze a front on a surface chart as active, stationary, or occluded? And what a coincidence. I just happened to show that just a minute ago. And like I said, that's basically just looking at your thickness gradient, or if you don't have thickness, look at your 850 and 700 millibar temperatures. And when you have the low back behind that gradient, like right here, that's a low pressure area, that's going to be occluded because it's detached from the thermal gradient to the south. Now, whether it's stationary or an active front, that depends on whether I'm seeing very strong flow across the front. For example, this is obviously a front right here. But I can see by the pressure lines that there's some pretty stout northwesterly gradient through here. So this is definitely a cold front. Now where it gets a little less clear is where you have like maybe a trough like this. Well, we know that this is probably a warm front, but if we have kind of like flow coming from the east up north like this, and maybe southeast flow like that, that might support a little bit more of a stationary front. So if I'm looking at flow that's kind of indeterminate, or it could be south or it could be north and I'm not sure, then I'll usually put that down as a stationary front. But even here it looks like that boundary there is probably a warm front because the synoptic scale flow goes from south to north like that. Okay, let's see here. 15 watching and 9 likes. 9 is pretty good. I appreciate 9 likes. Some people may be busy maybe making dinner. That could be one reason. But I appreciate those 9 likes. That's pretty good. And let's see. That's pretty much it for the chat. And I think that'll probably do it for me. So we'll probably have some weather to look forward to next week. I was going to cover a little bit more of the tropical lesson, but I'm probably going to have to wait till maybe this weekend. I was kind of putting together some notes and I got sidetracked, but we'll try to return to that pretty soon here. Anyway, that's about all I got for this evening. I appreciate you watching the webcast, and hopefully we'll see you tomorrow. Take care.